Welcome to TechBrain YouTube channel. Did you want to unlock powerful real-time insights from Bitcoin's price swings, all stored and analyzed in MongoDB? Today, I will show you how to ingest every minute of BTC USD data for 2021 into a MongoDB time series collection, run both basic and advanced analysis, and build live interactive charts with the Atlas Charts SDK. By the end of this video, you will be ready to spot trends, backtest strategies, and make data-driven decisions. Here's the roadmap. First, we will make sure you understand time series in MongoDB. Then spin up a free Atlas cluster, import and clean our 2021 BTC USD dataset. Run queries to calculate things like moving averages and volatility. And finally, build live charts that react to your data. No Python notebooks required. Time series data is simply measurements collected over time. Think temperature readings, IoT sensor logs, or financial tick data like Bitcoin prices. MongoDB's dedicated time series collections optimize for this pattern by reducing storage overhead and speeding up queries on time-based ranges. In this analysis scenario, we will work with every single minute of Bitcoin USD price data from 2021, all stored in MongoDB Atlas. We will leverage the aggregation framework to crunch the numbers and use Atlas charts to bring our findings to life. First, we identify trends and patterns. For example, pinpointing periods of sustained price movement or recurring daily cycles. Next, we generate basic and advanced statistics such as average closing price, daily highs and lows, moving averages, and volatility measures. Finally, we visualize insights directly from JSON using Atlas charts to render interactive time series graphs straight from our stored minutes level data. Before we proceed with our analysis, make sure you have the following ready: a MongoDB Atlas M0 cluster, the complete 1 minute historical BTC USD data for 2021, and also make sure you have the Mongo import tool installed for data ingestion. Familiarity with Unix timestamps and how to convert epoch seconds to BSON dates. Understanding of date field in UTC time zone, plus the key time series field, symbol, open high, low close prices, volume, trade currency or amount. We will follow a 6-step workflow to prepare, ingest, transform, and visualize our minute level Bitcoin data. Download the dataset via call. Import raw data into Atlas using Mongo import. Cleanse and standardize fields names and date formats with an aggregation pipeline. Save the result into a dedicated MongoDB time series collection. Build data analytic views where needed. Visualize directly in MongoDB Atlas charts from our JSON data. First, grab the 2021 BTC USDT minute data. Then download it. I have successfully downloaded it and unzipped it. Then import into a staging collection. Documents imported successfully, and we have 0 document fields to import. You can see that we've successfully imported our data using Mongo import. Now, let us create a time series collection. In the crypto database, click on this button to create a new collection. You can give it any name. I'm going to name it BTC USD time series. In the additional preferences, select time series collection. In the time field, fill it with this name. In the meta field, fill it with this name. In the granularity option, select minutes. Then click the create button. You can see we successfully created our time series collection. Time fields must be a BSON date. Meta field labels each series for query efficiency, while granularity aims at your data interval to optimize bucketing. The benefits of time series collection. MongoDB's native time series storage offers the following. It reduces input and output for read operations, smaller storage and index sizes, better in-memory cache utilization in wired Tiger, simplified time series query. Lastly, it simplified time series queries. Let us connect to our MongoDB Atlas from our terminal using Mongoose. So input your database access password. We've successfully connected to our database. Now let us use our existing database called Crypto.
Let us transform our raw staging data into the BTC USD time series collection. Here's the aggregation pipeline used. Step 1. We use the add feed operator to convert the Unix epoch seconds into a proper BSON date by multiplying by 1000. Step 2. We use the onset operator to remove the now redundant date fields. The last step, we use the out operator to write the clean document directly into our time series collection.
We have successfully converted dates from Unix epoch to BSON date format, removed the unwanted fields, and saved transform data to time series collection. Make sure you sanitize your staging collection in MongoDB. Copy the GitHub link in the description below, where you will find the commands to sanitize your data. Execute the pipeline from Mongoose to sanitize your data. If you see a Mongo network error connection closed when running this or any aggregation, it usually means your shell cannot stay connected to the Atlas primary node, often because your IP is not whitelisted in network access. Make sure your current IP is added under network access in Atlas. Then rerun the operation. That will keep the connection alive so your update can complete. When you create BTC USD time series, MongoDB under the hood makes a system bucket BTC USD time series collection. That is where the actual data lives, grouped into time ordered buckets for efficiency. Each bucket document tracks the mean or max timestamps and the symbol meta field, a compound index on meta control mean timestamp, control max timestamp. Let MongoDB quickly locate the bucket you need.
Now, let us build aggregation views or charts to compute and display the average price, price range, median price, volume analysis, and trend identification. These metrics give you a quick, actionable summary of 2021's Bitcoin market.
Let us add new chart to calculate the average daily price. We select BTC USD time series as the data source. We are going to create the daily mean of open and close for our BTC USD data by creating a non-materialized view. Now paste the pipeline into the chart search bar just like I did to pre-process your data for visualization. Let us format, then apply. The first project formats the timestamp as year, month, day and select close. While the group computes the 1-day average of close, then sort orders by date. Lastly, the set window fields calculates a 7-day moving average over daily average. Now, you can see we have it applied here. For the chart type, select discrete type. For the chart type, select discrete line from the drop down. For our x-axis, drag and drop the ID. While for our y-axis, drag and drop the daily average. Then also drag and drop the moving average. So let us sort it by category. You can give it a title of your choice. I'm going to give it a title daily average and moving average.
Now let us save and close. You can see we successfully add the daily average and moving average chart. As you can see here, the BTC USD time series has been selected as our data source. For the chart type, select the colored column, then paste in the pipeline here. You can format it, then click on apply. You can see we have the ID and the total volume of the USD. This groups all documents by their minute timestamp and sums volume USD for each timestamp. For x-axis, use the ID. For y-axis, choose total volume USD with some aggregation. Then for the color, now for the ID, you can change to show the weekday only. Select day of the week from this drop down. Now let us customize the ID. Let us change this ID label to timestamp. Click on these fields, then toggle this button to override the label. Now I'm going to change it to timestamp. You can see we have our label as timestamp. Our chart shows Monday with the tallest bar. That means Monday was the busiest BTC USD trading day in 2021. Next, we build a non-materialized view to compute daily trading volume metrics, including average, maximum, minimum, and total volume for both BTC and USD, and then visualize these metrics in Atlas Charts, just as shown on the screen, by pasting our aggregation pipeline into the charts search bar. We also use projects with date to string to group by date. The group stage with multiple accumulators, average, max, mean, and sum to calculate our metrics. And finally, sort to order our results chronologically. If you do rather prepare your data ahead of time instead of pasting a pipeline into the chart search bar, you can create a view directly in MongoDB, just as shown on the screen. Instead of pasting your entire aggregation into charts, run db create view command in MongoDB to materialize your transformations as a read-only view. Then simply point charts at that view. This sets up daily metrics view on your BTC USD time series collection. Charts will treat it like a regular collection, no extra pipeline pasting needed. We group all documents by the UTC day of timestamp. For each day, we calculate the total volume BTC, average volume BTC, high price or low price, open price or close price. Finally, we project only the fields we want in our view, dropping the internal ID and keeping our daily metrics plus the interval date. We've selected the daily view metrics as our data source. No further pipeline needed. You can immediately build charts on your pre-aggregated daily metrics. That is how you streamline your data prep by creating a view in MongoDB. First up, the volatility index, which measures price fluctuations over time using standard deviation. In an aggregation pipeline, you do use set window feeds operator to compute a rolling standard deviation of close prices over your chosen window. Next, correlation analysis lets you compare price trends with trading volume to see how strongly they move together. Why MongoDB doesn't have a built-in core operator? You can compute covariance and variances in separate stages of the pipeline, then derive the Pearson correlation coefficient. Finally, anomaly detection surfaces outliers, say sudden volume spikes using window functions. Compute a rolling mean and standard deviation, then flag points more than 3 times STD from the mean. Round numeric data for fewer decimals to boost ZSTD compression. Omits empty arrays or objects, so column compression stays consistent. Leverage columnar compression, data encoding bits packing for time series batch write with insert many method instead of individual insert one method calls. Set orders, force in insert many method to continue on errors and improve throughput. Increase concurrent client writing to the collection to maximize insert bandwidth. Use an immutable meta feed for time series filtering instead of the time field. Favor group operator over distinct operator for aggregations to leverage the aggregation pipeline's efficiency. Shard on the meta feed for distributed time series collections. Avoiding time field as a shard key. MongoDB's time series collections offer an optimized storage and compression. The aggregation framework powers advanced analytics and non-materialized views, and Atlas Charts brings your insights to life all without moving data out of the database. Hit like if you found this useful, subscribe for more MongoDB deep dives, and let us know in the comments which metric you will tackle first.